Objective 7. Identify sampling and non-sampling errors. Sampling error is involved in using a sample to estimate information about a population due to randomness in the sample. A sampling number does not equal a population number. Now remember that the benefit of using samples is that it can save us time, money, and effort. The somewhat bad news is that our inferences will have sampling error because a sample cannot be a perfect representation of the population. The good news is that if random sampling is used to select a large enough sample, sampling error will not be too large. So for example, if we're talking about the US population, 56% of college students are female. If we take a sample that 24 out of the 33 are female, that means that that's 73%. Well, the sampling error is taking the 56% from the US population, subtracting the sample percentage, which is 73%, which would then equal negative 17%. Now, a non-sampling error is error from using bias sampling. Sampling bias, non-response bias, or response bias, recording data incorrectly, and analyzing data incorrectly. So, for example, identify whether sampling error, non-sampling error, or both have likely occurred, and then explain. A student randomly selects students from her school, and by referring to student records and admissions, she accurately computes the proportion of sample students who are full-time students, which is 0.45. However, the population proportion of students who are full-time is 0.52. Well, first and foremost, we have the sampling error. We take the population proportion, which is 0.52, and subtract the sample, which is 0.45, which gives us a sampling error of 0.07. And then there's a non-sampling error because sampling bias, since they only used students from her own school. Next, a boss randomly selects some of the employees at her office and asks them whether they have ever called in sick when they were actually healthy. She accurately computes the proportion of the sample who said yes, which was 0.03, but the population proportion is actually 0.29. So the sampling error is taking the population proportion, which is 0.29, and subtracting the sample proportion, which is 0.03, which gives us a sampling error of 0.26. Now, what is a non-sampling error? Which is a response bias, since people would not be truthful to their loss. Now, for example, identify sampling and non-sampling errors. An employee in human resources randomly selects some of the employees, and by referring to accurate records, he correctly computes the proportion of sample employees who have worked at the company at least 10 years is 0.37, but the population proportion is actually 0.38. So there's no sampling error because the sampling is not biased. The data were recorded correctly and the analysis was done correctly. So the error is due to sampling error. An employee in human resources randomly selects some of the employees and asks them whether they have ever called in sick when they were healthy. The proportion of the sample who say yes is 0.05, but the population proportion is actually 0.28. It is very likely that some employees did not admit they had called in sick when they were healthy. So it is very likely that the response bias occurred, which means non-sampling error occurred. It is also very likely that the sampling error occurred because sampling error almost always occurs even when sampling is carried out correctly. In this next example, we have the music preferences of students' class are shown in the table below. So here we have 1, 2, 3, 4, 5, 6, 7, 8 students, and then their music preference is listed there. What we want to do is we want to use a calculator with a C to 95 to select 4 students. So I'm going to go ahead and use the 95 seed. So we're going to put in 95. And then we're going to store it and then go to math, go to probability, and then store it into RAND, and then press enter. And we're going to go back to math, and then we're going to go to probability and then scroll all the way down to number 5. And there's 8 students that were selected, so it's going to be 1 to 8. And what we want to do is we want to select 4 students. So if we select 4 students, we have 7, 3, 4, and 5, and none of them are repeating, so we don't need to hit enter again. So what that means is we have 7, 3, 4, and 5. Well, number 7 is Mark, number 3 is Maria, number 4 is Chris, and number 5 is Maya. Okay, now for the simple random sample that you selected in part A, we want to find the proportion of students who prefer EDM and write your results as a fraction. Well, there's only one student that likes EDM, so that's 1 out of how many from this sample, which is 4. 1 out of 4 is 0.25, which represents 25%. Now, for all students in the table, we want to find the proportion of students who prefer EDM and then write your result as a fraction in percent. Well, for all of them, it's 8. So 1 out of 8 is 0.125, and therefore that's 12.5%. Now, does your result from part B equal your result from part C? If no, is this due to sampling or non-sampling error? Well, no, because they are not equal, and therefore it is due to sampling error.